Triangles are cute little things, but there's something you might not know about them, and that's what the angles inside of a triangle add up to. This video is going to focus on the angles inside of a triangle. You may know that the angles on a straight line add up to 180 degrees. If I draw a straight line in yellow, that should be, and if I drew an angle on that, which would be a semicircle, starting on the straight line and ending on the straight line, that would be 180 degrees. But how on earth can the angles inside of a triangle add up to 180 degrees as well? That seems implausible. Let's check it out. Using cutting-edge technology, not really, but using some technology, we're going to cut out these corners of the triangle and see if they add up to 180 degrees. This is going to be pretty cool. Let's copy that and let's paste it down here. There's our first corner, the red corner. Let's cut out the next corner, the blue corner, and then we'll see exactly how they fit together. There's the blue corner, we copy it and put it down next to the red corner. There it is. They're beginning to slot together. Finally, we can select the green corner, and when I paste it, we'll have the moment of truth. If I was right and the angles inside of a triangle add up to 180, when I cut them all out and put them together, they should form a straight line, all fitting nicely together. Here we go. Dun, 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 dun. There we go. They fit perfectly inside. In other words, just like the angles on a straight line, they add up to 180 degrees. Right, using that knowledge, we can draw all sorts of triangles, and we're always going to know what the angles inside the triangle add up to. Let's try for our first triangle. Let's try a right angle triangle. How about if we draw the right angle triangle in green over here and fill it up with the background colour. There we are. We know it's right angled because there's a little corner box like so. They would give us one of the angles inside this triangle. Let's say they give us 30 degrees in this corner here. And your challenge is to work out the angle X. Sounds a little bit confusing, but we need to rely on our knowledge, which I'm going to put down below that in a bigger font than that. I'm going to put the knowledge that we've just learned down below. Angles in a triangle always add to 180 degrees. And let's write it all the way along the bottom like so. I'm even going to highlight that just because I think it's such a cool fact. There we are, and fill, no fill, like so. Okay, in the triangle, what angles do we know so far? Let's choose a different colour to that. Oops, not that colour. How about a nice and simple red? There we go. The angles in a triangle always add up to 180 degrees. The angles in the triangle we see to the right that we know are the 90 degrees, which is the little box, and the 30 degrees. We need to work out what's left over because we know all three of them are going to add to 180 degrees. 90 plus 30 equals 120. So if we do 180 degrees, which is all three of them, take away 120, we would get 60 degrees. And indeed, the angle X is 60 degrees. How did we work that out? Well, we added together the two angles that we know, and then we knew that all three of them would be 180, so we did 180 take away the two angles. 180 take away 120 is 60 degrees, so X is 60 degrees. Let's try a harder example. How about if we had a straight line and then drawn onto that straight line we have an isosceles triangle. There's one side, and there's the other side. And we know it's isosceles because it would have two marks, like so, showing that these two sides are equal. All we're going to be told is that this angle on the outside is 140 degrees. That angle on the outside is 140 degrees. Now, we need to put together all the knowledge that we've learned and try and find out this angle on the right, which is y. Here's how we're going to do it. If that angle on the outside is 140, what's the angle on the inside of the triangle? Well, we know from that first experiment that angles on a straight line add up to 180. So if that angle on the outside is 140, the angle on the inside is 180, take away 140, which is 40 degrees. So the angle on the inside is going to be 40 degrees. There it is. Now we're going to have to rely on our knowledge of isosceles triangles. Just to spell that so we can see what we're doing, isosceles. The cool thing about isosceles, which is the triangles when two of the sides are equal with those two little lines, is that the two angles at the base are equal. If I just draw another isosceles over here just so you can see what I mean. The two angles at the base, in other words, the two angles at the end of the two lines that are marked down here are always equal. That's a cool fact about isosceles triangles. If you see this isosceles triangle, that means this angle and this angle are going to be equal. Well, we've already worked out that the angle in the bottom left is 40, so that means the angle on the top left is also going to be 40. But now we're kind of stuck. Fine, we know that's 40, and we know the other angle's 40, but how would we find y, which is the one we care about? Well, we use our knowledge that angles in a triangle always add up to 180 degrees. So far, we have 40 degrees and 40 degrees, which it adds up to 80 degrees. If we do 180, which is all three of them, take away 80 degrees, what we're left with is it must be the angle y. So what we're left with is 100 degrees,